Hey everybody, thanks for watching the videos, and I apologize for the delay. I got a little backed up this last couple of weeks, and now I'm trying to play catch up on it. But needless to say, in this video we're going to cover inferential statistics. So as we go through some of these topics, I want you to remember back to when we discussed differential statistics way back when, and just kind of use that as the stage for the setup, what's about to happen here. During this video, there's probably going to be another series of videos here, so we're going to really hammer in the topic or the information for this, and then another series of videos or a few videos we're going to talk about the different type of statistical tests. So one thing I want you to understand while we're going through this, again, it's not a statistical class, so we're not going to plan on doing a lot of practice on how to formulate things like a t-test, but it's going to be more a drive towards how to read the results of a t-test. So here we're going to look at what hypothesis testing is. We're going to give you a fundamental basis on what that goes through, the difference between independent and dependent variables. We're going to take an overview on the hypothesis testing. So again, that's a different part of the section, so there's more information. The statistical tests, kind of where it gets into the hairy or the murky waters for this chapter or this topic. And then we're going to talk about, briefly, we're going to talk about the different type of tests, because like I said, I'm going to cough up some different videos. We may go into depth with the chi-squared or the x-squared test, just because it's not a lot to go over in that one. It's pretty simple, straightforward. So the other ones do definitely warrant some individual attention. So here are the terms for this section. These are the words that I do want you to be familiar with as I go through the video. You may have to pause the video again to go through the textbook and write down the definitions and make your flashcards off of this one. But needless to say, this is where the context of this video is going to come from. And as always, it's not a statistical class, so in this chapter we're going to cover the topics of these tests later on. But as far as the math is considered, you've already learned most of it from differential statistics and reliability. So moving forward onto that, hypothesis testing. So what the crap is inferential statistics? Basically, it's when we take the results from a set of descriptive statistics and relate them to a larger population. So now when we're testing people, you have your control group and you have your tested group, and then who do they relate to? So that's where we use inferential statistics as far as like developing who those populations should be representative of. Much of human research performance uses inferential statistics, in their results. So I wrote a paper over the course of this last summer. It had to do with Gatorade, and in that paper I had to use quite a bit of inferential statistics to basically relate how sprint performance relates to like body fat composition, blood pressure, and things like that. So here what we're looking at is the H0 or the H1. And I don't mean histamine receptors. I mean like whether H0 is called the null hypothesis, and the H1 is the accepted or the alternate hypothesis. Not accepted, it's just the alternate one. And you can have multiples. So you would have H0 or H01 indicating that you have two nulls. And we'll talk about that again once we hit the different types of dependent variables that have to be evaluated. But same thing with the alternative hypothesis. So you have an H1 or an H11 basically. So the H0 in my example here, fasted cardio, has no, and you see how it's bolded, has no relationship between fat loss and increased aerobic performance. Basically what we're saying is that there is no effect on the cause. So the accepted, or not the accepted, the alternate hypothesis, the H1, suggests that fasted cardio has a relationship between fat loss and increased aerobic performance. So we're assuming that there is a relationship between both of those dependent variables to you being fasted. So hypothesis testing is basically used by the scientific method. So the scientific method isn't exactly something we cover a lot in the exercise science world, but as far as the basis of science research. So when you look at the scientific method, you see an observation, you kind of think about why that observation is occurring, and then the resultant of that thought process should give you what's called a hypothesis. Again, we talked about hypothesis already, but from there we go through our, standard procedures to prove that hypothesis or disprove that hypothesis. So what is a hypothesis? It's a statement of a presumed relation between two variables in a population. Again, we were talking about your control and your measurable population. So in my Gatorade study, I had a group of people that were given a Gatorade supplement. Basically, they had an 88 calorie or 80 calorie drink prior to their 10 sprints. And then I had another group which did not get that same Gatorade. They got a Powerade, which was 0 calories. So basically what we're looking at is the control group is the 0 calorie group, and the active group is the one given the Gatorade. So the control group can also be called the placebo group or some other type of group, but those two should represent relatively the same population of people. So in my test, I used active participants from my gym who, were forthcoming. They were all female, and they were able to meet me at the times that I asked for them to. So the day 0, I got all their data, their resting data, and moved on from there from day 1. And then we did our 10 sprints that correlate with it. So they all represent generally the same population. But again, that's another class that we could talk about. But what is a population? The group of people or observation in question. So the student body is a population. However, within that population, the Department of Kinesiology could be considered a sample. So I've already talked about what parameters I used already, but now let's talk about what a parameter is. A parameter is a measure of interest within a population. So basically, I wanted to see if Gatorade does help improve the sports performance of sprinting. So the Gatorade with the sugar and all the calories that are associated with drinking a Gatorade prior to their exercise, that's kind of where I was trying to get at. So the result of me testing these 7 or 8 individuals ended up with a sample which is called a statistic. So now I was able to take all this data, put it in a spreadsheet, and start formulating different theories and hypotheses based upon the numbers and the results that I got. So that was a statistic. Here's a short table from the textbook, table 5.1. Basically, these are just difference or change symbols to be familiar with. So whenever you see that, I guess it's a micro. I don't know, in chemistry, when you're measuring stuff, that little symbol means micro, but it's in here we're using it for mean. So when you see these pop up on the formulas, just remember to refer back to this, and you can kind of remember the difference there. So like that little P is now your Pearson product correlation moment, or the R. The standard deviation has that weird looking O with a dash across the side. S. So again, refer back to this when you start seeing some of those formulas. Here's another example of hypothesis testing. So in research, what does the researcher actually what the researcher actually believes will occur? So here I have an example. I believe that fasted cardio will decrease my non-essential body fat, right? That's a hypothesis. So look at what's happening here. We got 2 dependent variables and 1 independent variable. So we're looking at how body fat and aerobic performance change over the fact that there's a fasted state. So the null hypothesis, again, has to do with there's no change in body fat composition or your athletic performance, versus if there was a accepted hypothesis, which would say there was. Basically, it's the same sentence, just the change of 1 or 2 words makes that whole context completely opposite of each other. So first you need to select your probability level. So this is where those alpha numbers come back into play, and you talk about that 0.01 or 0.05 alpha level. So anything that's below that 0.05 is acceptable, or anything below that 0.01 is acceptable. Most people tend to set the number to 0.05, just kind of gives them a little more leadway to make a reliable solution. So when you look at the difference between fasted cardio and non-fasted cardio or aerobic fitness, the populations generally have that 0.05 population so that you can have a group of scientists who agree that it does, benefit the individual. It could still fall within that 0.05. Conversely, with those who suggest that it's, asinine to be performing aerobic fitness fasted, and they can still use that 0.05. So it's a good example to show how, one, a 0.05 gives you a better measure versus the 0.01, and two, how there's always going to be two camps of the same topic trying to, relay a better or a more reliable source of information. So as we tunnel down towards the end of your scientific method or your testing or research project, what you see is that you either have to accept or reject your null hypothesis. So what occurs out of that is either you have a good rejection or a good exception, and then you have, your statements are true. But then again, when you reject a hypothesis or reject a null hypothesis when there's a relationship there or a significant relationship, that's considered a type 2 error. Whereas if you accept the alternative hypothesis when the null hypothesis was true, then that's type 1 error. So when you determine there's a relationship but there isn't, type 1. When you determine there isn't a relationship but there is, basically, then that's type 2. So both type 1 and type 2 cannot coexist in the same field. So again, part of the scientific method is determining if the results are, one, reliable, and two, if they're not, what can we do to change them to make them more reliable, essentially. So keep that in mind as we move forward, because we're going to start talking about the different types of inferential statistics here in a second. Just to give you a quick summary, and I know I'm kind of going through this hot and heavy right now, but I'm assuming that you've probably read the chapter thus far. Here, step one, you develop a research hypothesis. That's, again, you see an observation, and then you make a guess about why that observation is occurring. Two, you state a null hypothesis. So 2 and 3 kind of work simultaneously with each other because, like I mentioned earlier, the change of 1 or 2 words makes all the difference in your null and alternative hypothesis. Then the next step is to collect data to either support or disprove your null hypothesis. So, obviously, if fasted cardio does not have any relationship on body fat and athletic performance, then that's what my data should show. Now, if my data starts showing the alternative, and moving in number 5, then I have to accept the alternative solution to that. Hopefully not making a type 1 or a type 2 error, thus having to go back to the drawing board, recycle the entire scientific method, because science is always tentative, it's never absolute. So keep that in mind as we start going into a little bit of the stuff now that makes people have headaches. I know it's partially the reason why it took me a little while to cough up these next videos, is basically because I didn't really know how to tackle the information without it being overwhelming. This is the first of the next series of inferential statistics. The first one is the chi-squared, so the selected statistical statistics. And again, we're going to go through the fundamentals here, and then we're going to do different videos per the type of test. However, basically what chi-squared is to do is to determine that if there is an association between levels of 2 nominally scaled variables. So if you date yourself all the way back to, I think it was chapter either 2 or 3, when we talked about nominative as a description. So it's not nominal as in numerical, it's nominal as in groupings. So like your males versus females, your master age versus the youth age. Was another good one. The athletic versus the non-athletic, or those who exercise and those who do not exercise. So here's the formula that's associated with it. I'm going to make a separate video based upon this formula by itself, so we can get a little bit deeper into it. But basically, all we have to do as exercise scientists, and for the purview of this class, is really just know how to read the results. So we'll get into that. The next test we're going to cover is the t-test for 2 independent groups. Basically, what we're trying to do is examine the differences in one continuous dependent variable. I put there the y variable between 2 or no more or no less. So basically it has to be two independent variables. So basically if you look over here, again, I'm going to get into the mud with the next video, but you see that there are two independent variables, which we're classifying in this as varsity and sub-varsity or junior varsity for some of us who speak English. And you'll see that there's a whole bunch of data below that. That is indicating that both of those varsity teams, or junior varsity and a varsity team, is your independent variable. And we, in this example, we're testing serves. If the training of the varsity team is better than the training of the JV team. So basically the training would be your dependent variable. So keep that in mind. Again, very broad stroke here. Just be familiar with the test and what it tests for. The next t-test is the t-test for paired groups. So basically we're comparing two related or paired groups on one dependent variable. Now that's just straight out of the textbook, but to kind of give that added context, you got to look at the bottom where it says the same person makes two measurements. So in the textbook, it gives us, let's say, the varsity team again. However, we did a positions test for competition, who gets to play first string or whatnot, preseason. So everybody performs in their position, does everything, they get scored for it. Then again, after the season, we do the same thing. So that's basically, instead of going JV and V, it's just one of those teams with their pre-test and their post-test. So again, kind of sounds like that, what is it, summative almost, because you get your pre-test and then you would go through the entire season, you do your post-test. So tying that back to chapter 1. So that's how we kind of read the t-test here, or that's what this test is specifically related to. We read this by understanding the significance and the F value. So again, we'll talk more about those in the next video. If you recall back to the t-test for independent groups or variables, it said no more, no less than 2. So when we have more than, let's say, 2 independent variables and 2 dependent variables, and it could get kind of timey-wimey, or can get really confusing with all the different numbers and data that you collect. ANOVA is a really great way to start comparing that data, because here you can see the one-way ANOVA. Its purpose is to examine a group differences between one continuous dependent variable and one nominally scaled dependent variable. So unlike the t-test, the ANOVA can compute independent variables with more than 2 groups of data. So now when we're looking back at the facet state thing, right? So we have, we're trying to analyze 2 different types of measures here. So whether you are fasted, which obviously becomes that independent variable, now we're analyzing that with 2 different dependent variables. But then again, we can add in another independent variable, and that's where the two-way ANOVA comes in. And that's where we determine different groups between one interval or a ratio, dependent variable, and 2 nominal independent variables. So basically look at table 5.7. Look at, and again, we're going to discuss this here in the next video, but just look over those numbers, kind of get really familiar with what you're seeing there. The takeaways are going to be the significance value, and I think it's the p-value. So keep that in mind as we move forward. So that's going to be pretty much it for inferential statistics. This was pretty much going to be the fundamentals video. So get familiar with the terms, get familiar with what a hypothesis is, and the null and the alternative, and what a type 1, type 2 errors are. I was looking over the pictures as I was going through this video. I think the picture that I have is not the same one that's in your textbook. So use the one that's in the textbook. Obviously, the material I'm trying to cover is based off of here. If you haven't done so already, take the opportunity to subscribe to my YouTube channel. It helps you, first of all, to get the information as I publish it. So, and secondly, it becomes a marker for you to be able to go back and reference. And this is how you do it. Basically, you just go to YouTube, log into your account so that you have a free Gmail account, and then type my name. When you see that, you should see a little button that says subscribe. Once you click on the subscribe button, a little bell icon pops up, and basically when you click on that bell icon, that's when you have a full subscription to my channel. So again, like I mentioned, whenever I publish a new video, specifically like how we're going to have these next series of videos coming out pretty much a relatively short period, so you won't get behind in the material there, and you'll always have some type of quick reference to, refresh your memory on prior to like your exams or prior to your lectures or anything like that. So again, my name's Andy. Thanks for watching, and I'll hear from you soon.